Hi, students. I'm Rich Malloy. I'm your professor for data-driven leadership, and I'm excited about taking this journey with you. Let's get right into it. Week one contents. Tonight we're just gonna review the syllabus. We're gonna review course overview and map. Review the graded assignments in this course, and then we'll review this week's assignments. And then finally, there'll be a short lecture on the terms and the foundation principles of data-driven leadership. So in terms of the syllabus is up on the webpage. Please take a moment to review it if you haven't already. And if you have any questions, go ahead and send those to me early in the course so that I can answer those for you. The course looks something like this. At the beginning, there's an introduction. It's short. It's probably half a week or so. And then we get right into data analysis and workplace decisions. We do that in the first week, and in addition to doing the introduction. And that lasts about 4 weeks. It's about half the length of the course. And then we get into how to do a needs assessment / performance analysis. And that will take up about 3 weeks. And then finally, we'll look at data for the personal leadership plan or project. And this is data that also can be used in strategic planning. And it's mostly getting familiar with the terms regarding that type of data. Here's another way to look at the course in terms of a breakdown of weeks. The student learning objectives, the readings, the assignments, and the portfolio items. In this case, the portfolio items and the signature assignment is a report that's going to come out of an analysis that you will all do. That's the SNA report, Strategic Needs Assessment Report. It also can be titled the Needs Assessment Report, and alternatively also Performance Analysis Report. And we'll get into that when we get into that subject towards the middle of the course. And then finally, a memo on how to use data to make better decisions in the workplace. And that memo is due at the end of the course. And it also gives you an idea where the bulk of the course grade is. You can see that the first 4 weeks is about 34%, and then the remainder is going to come from the final 4 weeks of the course. So a little bit more in the final. It's like a 60-40 split. 40% in the first 4 weeks and 60% in the final 4 weeks of the course. The graded assignments. So there's going to be 25% of the grade is going to be in quizzes. If you took my communication course, you'll be familiar with those quizzes, the way they're developed and also assigned in the course. Then we have sharpen your pencil activities. This is going to be another 25% of the grade. And these are basically assignments where you're working in the textbook and working alongside the textbook to gain an understanding for the material. There's a short video that you will present in the middle of the course. It's worth 10% of your grade. And then finally, the analysis and the report as the bulk of the grade there, 30% in terms of, for assignments, it definitely has more points than any other assignment. And then finally, the memo, which is 10% of your grade. So this week's assignments, you're going to write or record an introduction and post it by Wednesday. If you've already done that and you feel like you kind of, in previous courses or in the previous course, and you feel like you know most of the people, I'm asking you to do it again just because there might be a few new individuals in this course that did not take the communication course last semester. So if you could do that, that'd be great. If you want to mix it up a little bit, this time I'm offering an alternative to writing your introduction. You can post a short video, less than 5 minutes. And then you'll do the sharpen your pencil assignment. It's for one chapter. In the future, you'll have multiple chapters to do. So this is just kind of to get you in the process of doing these sharpen your pencil assignments in the Head First Data Analysis book. If you don't know already, this book is downloadable as a PDF, and you don't have to purchase it. So if you're saying, shoot, the instructor didn't tell me which book to buy, that is because this book is available without having to purchase it, and it's available by download, so you can get it tonight. This assignment is due Sunday, and all assignments will be due at 11:59 p.m. So at the end of the day, whatever day it's due. By the way, I will say that the second textbook you should order soon, because we'll need that about halfway through the course in about 4 weeks. In tonight's lecture, we're going to go over the following terms. These are like kind of some baseline foundational ideas with regards to data. First of all, qualitative versus quantitative research. Both are valuable. In this course, we're mostly going to be dealing with quantitative research. And that is research, if you have enough of it, you can make generalizations. Qualitative research is not interchangeable with quantitative research. However, it does have its own usefulness, and that's going to be in understanding the how and the why behind a phenomenon. When you think of qualitative research, you should think of something like an anthropology study in which the researchers might live with the population that they're trying to understand better. So they're getting that rich qualitative data from being immersed in the environment. Another couple terms that get confused sometimes are validity and reliability. And validity is basically the how effectively something measures what it's supposed to measure. And I'll give you an example of darts and a dartboard. We have 4 targets here. The first one, you can see the dart thrower is all over the target, right? So in this case, we would say that dart thrower is neither reliably hitting the target, and they're not valid either in terms of hitting the target. And the second one, now we see a cluster down in the bottom left corner. Now, in this case, we say that this dart thrower is reliably hitting that left bottom corner of the target. However, that's not the objective. The objective is to hit the center of the bullseye, and therefore we would say this person does not have validity in their throws. They have reliability, but no validity. And the third one, you can guess that this is both valid and reliable. The dart thrower is hitting the mark, and they're hitting it consistently. And then in the fourth option there, the dart thrower is mildly valid and reliable, right? Another way to think about validity and reliability is in terms of an IQ test. Say I developed an IQ test and I gave it to some students. Say that student A took the IQ test, and it showed a score of 80 out of 100, say. And say I administered it to that same person a few weeks later, and they scored 80 out of 100, or roughly around the same score. We could say that instrument has some reliability. It's consistently getting a similar score for that same individual. However, if we find later that my IQ test that I developed has no basis for measuring intelligence, and that can be proven by giving another validated intelligence test and saying, well, this one measured this and yours measured that, and it's not the same. So if my IQ test doesn't measure intelligence, then we would say that IQ test is not valid. Could be reliable, but it's not valid. So I hope that it helps you understand validity and reliability in terms of data. Another couple terms that get mixed up sometimes when we're talking about data are causality and correlation. Now, a couple of variables are on this graph. One of them is IQ, and another one's radon. If you don't know what radon is, it's a gas, and it's a radioactive gas. So on this graph, it would look like the higher the radon levels, the lower the IQ. These dots on the graph, or the scatter plot rather, is our individual scores, IQ scores, and also radon levels, right? So they would measure both exposure to radon and also IQ scores, and they would see that, oh geez, the people that have the most radon have the lower IQ scores. Now, the reason I'm showing you this is because this is not, in fact, a causality. In this case, radon does not have any basis on your IQ. Now, it does cause lung cancer. It's the second highest cause of lung cancer, but it has no bearing on your IQ that we know of. So what's going on here? It's a little bit misleading, right? The way the data looks. And so when you see something like this, you don't want to jump to the conclusion that there's a causality. There's appears to be a correlation, but we don't know what's causing what, right? And in this case, if we see these clusters, radon happens to emit from lead. As lead decomposes, radon is released into the environment, and so one reason you might have a graph like this where there is no causality is in the case of a third variable, in this case lead. So what the researchers weren't measuring in the first graph was lead, and so they didn't see that's where the real connection is to IQ. The more lead in the environment, the lower IQ scores, and that has been proven through research. So causality, correlation, you want to make sure that you're not jumping to the conclusion that there is a causality. Causation is the same thing as causality, and that's a cause and effect relationship. Correlation, when two variables are related, and it doesn't necessarily have to be a cause and effect, as we saw with the radon there. The mean is the average number in a data set. The mean is not always the best number to use when you're looking at data. Sometimes the median is a better indicator of data. For example, if you're looking at salary schedule, say the average salary of a high school graduate versus the average salary of a college graduate. If that number is, if those two numbers are reported in the press, they're probably using median, because a median score is not going to be affected by the outliers, right? If you have, say, a couple people making $1 billion a year, those people in either population are not going to throw off your data. The median is the middle number, so it would be the middle salary in this case. If you had salaries ranging from 36,000 to 80,000, you would look for that middle number, and that's your median. The mode is the most frequent number in the data set. If you had, and if we go back to the data on salaries, say there were 5 people out of 50 people that were making the same exact salary, say 40,000 a year, that would be the mode. They would be the most frequent. And say there's nobody, none of the other data is more than 5 in a data set. So standard deviation is a number that refers to the distance variance from the average or the mean in your bell curve. You might remember that standard deviation would start in the middle. You'd go out one standard deviation, you get the majority of your population or sample size, and then you go out a second standard deviation, and you get even more, like say 97% of the population, and you can go three standard deviations and get within 99% of all the people in your data set. We do have a free stats book if you want to brush up on some of these terms and your statistic. I will post that to the website under the recommended textbooks. Thanks. Now I'd like to switch a little bit and look at models for data-driven leadership. All these are, there's infinite number of models. I'm going to just look at a few of them. Basically, the idea here is that each one has a point where they say there's a problem or opportunity, and then this leads to a series of actions. So in model 1, this would be a no analysis decision-making model. You have a problem, you define it, and you take action. Now, in most cases, you'll see this type of decision-making model in emergency responder jobs. These are highly trained people that have already trained and they know what the appropriate action is for all the, or at least most of the things that they will encounter on the job. A shoot, no shoot type of decision has to be made super fast, and so this is the type of decision-making model you'll see with those type of jobs. But it's not the best for the other jobs where you haven't been highly trained to respond in that fashion. If you have the time, you want to take the time to analyze the data. So the second model is called the wisdom pyramid, and this is an example of a stoplight turning red and what a driver needs to do. You can see how artificial intelligence would use this type of model when self-driving cars are on the road driving everywhere. The car would receive the raw data, and this case it would be like an IP address with a number that signified that the light was red. the information as the car is approaching the light with a south-facing traffic light on the corner of whatever street has turned red. That's the meaning. The context, car is traveling towards the red light. So there needs to be an awareness that this is important information to take into account. And then finally, the wisdom level. There's a decision to stop the car. The data is used. Now, that pyramid model doesn't really help us in most cases. In the real world, as I said, it's probably one that I think could be most readily applied to artificial intelligence. But for us, Model 3, which the textbook Headfirst Data Analysis promotes, is one that would probably be useful to us if we decided to adopt it. In this model, you define the problem, you disassemble or break down the problem into smaller pieces. This is actually a way of analyzing the data. You further evaluate the data or analyze the data once you have it broken down, and then you make a decision or recommendation. So break it down, analyze it, decide. And then finally, and this one is taken from a needs assessment type of approach or a performance analysis approach. You would define the problem, you would gather data on your problem, you would construct knowledge from that data, you would make a decision based on that knowledge, and then finally you would evaluate the results and hopefully improve the decision by constructing new knowledge and making a new decision. And this could go round and round, several iterations to continue to make a better decision. So there are some things that you should be aware of when you start to use data to make decisions. One of them is about triangulation. And triangulation is a term that's used for referring to when you have multiple sources of data and you use multiple sources of data to come up with your recommendation or decision. In this example here, we have interviews from leadership, survey data, and then earning reports. And we look where those sources of data corroborate each other, and that is where we're going to find our problem and opportunity in the workplace, but also the area that is most likely the best to focus on. Analysis paralysis. All data has a shelf life. If you spend 6 months collecting data, that's probably too long. The data you collected at the beginning of that 6-month period is probably not valid any longer in a lot of cases. So really what this is telling us is that we want to do a good job. We want to collect data. We want to analyze it, but we don't want to get bogged down in the analysis process. We want to be able to move quickly to the decision-making point and implement something, and then go back, do it again, collect new data. And then finally, make a recommendation. I think a lot of people are gun shy when it comes to making recommendations in the workplace. This is that, I would say, healthy risk-taking behavior. You want to take some risk in the workplace. You want to, especially if you've taken the time to thoughtfully analyze a problem or opportunity. You want to present that data in a professional way, and And the reason you want to do that is a lot of the folks that you work for might not have the luxury to really analyze data and to gain a thorough understanding of it. And so what they're looking for is they're looking for a condensed or a consolidated or reduced version of that data. You know, what is it? What does it all mean? What's the likely best choice? You know, and the given the situation, and you should make those recommendations. You should make them with qualifications or caveats that if you have any doubts or if you have any specific reason to doubt your data, that you state that you don't hide anything, and but that you stand by your data, and you also take your best shot at what the best way forward is, given everything that you've looked at. This is the type of behavior I think that leaders show as they're going up the chain of command in their workplaces, and also that once you're in a leadership position, this is the type of behavior that you value from your subordinates. So this is the type of behavior that you're going to say, I'm impressed by this person. And if that person is the one that's asking for the raise or asking for a letter of recommendation or a reference, that these are the people that you're more likely to feel comfortable giving those references to, because they have shown the ability to analyze and make decisions based on data. Lastly, if you're really interested in data, you should take a look at this TED Talk on big data. This course is not about big data, but big data is really important in today's world. If you think about the Walmarts, the Amazons, the Apple, the Facebook, Google, all these companies are using big data to figure out what to market to us, and to figure out all sorts of decisions. And it's not just for-profit companies that are doing this. The World Health Organization and NGOs, nonprofits can use big data to help them make the best decisions they can to help people in the world today. So if you're interested in big data, if you like this course and you want to go further,